Consider the following ANSI C code. We have a code, right? Some C code we have here. Let's see the data first. Assume that the variable y points to a struct. Variable y points to a struct containing two fields f1 and f2, like y arrow f1 or y arrow f2, as you know, y points to a struct. The local variables x, y, z, p, q, and I are allotted registers. Okay. Common subexpression elimination optimization is applied. So if something is already computed, you don't need to compute again, so you can reuse it. Okay. The number of additions and dereference operations in the optimized code respectively are. So once you optimize, you know, how many additions and how many dereference operations are needed. So we have the 4 options here. Let me come to this code and look at, there are so many additions and dereferences, but if anything is looks same, just you don't need to compute. See, y derives f1 is computed twice, you can compute once, right? Y derives f2, you can see that it's computed twice. You can compute outside, you can reuse it, because loop needs multiple times to compute, that gets more operations. We need to optimize it, right? So these things you can compute outside. Even x plus 3 is there here, and you can see it's already there. So these are the 3 things you can, 3 common, you have here x plus 3 also. Okay, so x plus 3 is there, one common subexpression y arrow f1, y arrow f2. So you can reuse them. So compute them. X plus 3 you compute to one any temporary variable, let's say t1, and y derives f1 you can assign to t2, and y derives f2 you can, only common subexpression elimination, right? This is how you do it. You compute them first and reuse wherever you want it. Okay, so any other, no other, right? That's it. I think now z you need to compute, right? T1 plus t2 plus t3, t1 plus t2 plus t3, you do it, fine, semicolon, of course you can keep it if you want to write C code again. Okay, now for I is equal 0, for I is equal 0, I less than 200, and then I is equal to I plus 2. You cannot minimize this, because I plus 2 anyhow you need to compute. It's not computed, it's every time you need to compute it. Okay, then what else you have inside the code? If condition, if statement, if z greater than I, you have code here. What is there? 2 statements, that is p is equal to p plus x plus 3 is computed in t1, so you reuse the t1, don't compute x plus 3 every time. Then q is equal to q dereferencing with what? The q arrow, it's accessing the member f1, right? Okay, f1, oh sorry, q, what I'm writing here, q plus y arrow f1 is already computed in t2. Okay, then that's it, that's if is over. Then else, what is else here? The else I'm writing here, or you can write here itself if you want it. Okay, let me write here as per the structure. Else you have again 2 statements, p is equal to p plus y arrow f2, that is t3, and then q plus, what is that common subexpression? X plus 3, x plus 3 is there in t1. Okay, this is your program. Okay, we have closing here, else, and then whole program. Okay, the whole program is closed, and for loop is there. Okay, for loop is closed. And now you need to find out how many additions and how many dereferencing. Okay, so now let's look into it. So these are the 2 dereferencing. So this one is 1 dereference, I can just write directly here. We are using 2 dereferencing here, 2 dereference, nowhere else we have used 2 dereferences, nowhere else, right? That's we have used, reused the t2, t3 wherever you want it. And here 1 addition, the x plus 3 is 1, and then 2, 3, total 3 additions here, 1, 2, 3. So if you see here 1 addition, and here 2 additions, to add additions. Okay, additions. And now what else? Now look at 0 to 199, 0 to 199. So less than 200 means less than or equal 199. 0 to 199 means 0 to 198 tak. So how many times this is executed? Is it 200 times, or you know, see, I is equal I plus 2. Every time you execute, either if or else is executed, right? You never come out of the loop. So if or else definitely executed, but how many times you enter inside this for loop? Inside this for loop, how many times? Is it 200 times or 100 times? 0 to 199, in between every time you are incrementing twice, 2, 2, 2, 2 plus 2, 0, 2, 4, 6, 0 to 198. So plus 2, plus 2, plus 2 you are doing exactly 100 times you are entering it. So 100 times you are entering, here you do 100 times increment. Last time when you do increment 100 additions, last time you make the 100th addition, right? Then this will go beyond, then it will come out. So you need 100 additions. For 0, no addition, but after 0 executing, then 0 plus 2, when you go to 2, you got a 1 addition. So now at 2, 4, 6, 8, 198, 200, when you get 200, the value come out of the loop. This control will come out of the loop. So 100 additions will happen here. Out of them 99 additions to enter, 1 addition to come out of this loop. Now either you go to if or else. How many operations are there? Here 2 additions, here 2 additions. So definitely either you will enter if or else, right? So where you enter if or else doesn't matter. So always every time you enter, 2 additions only will happen, nothing else. Okay, 4 additions will not happen. Either if or else will execute. If enters if, 2 additions, or if enter else, 2 additions. So every time you enter for loop, 2 additions. 100 times you enter. So total in the loop, 100 multiply with 2, 200 additions plus 100 additions to increment the I value. Total here 300 additions, and in the program 300 plus 2 plus 1, that's overall additions we need. Overall additions 303 additions, and then 2 dereferences. 2 dereferences. Now let's see which option matches here. 3 additions and 2 dereferences. This option D is the correct. 303 and 303 additions and 2 dereference operations. Okay.